Ready to go? All right, hey everybody, my name's Stephen Deck. So how many of you guys work in the APPSEC field? Anybody? Okay, some people do at least. I think a lot of times people think that developers really aren't doing their jobs. I know yesterday we had kind of a throwdown in one of the talks about if developers were like the source of some great problem in our industry. I don't really blame the developers. I think devs have problems because we don't really give them enough tools. And so that's kind of what this presentation is about. So I want to give everybody some information on how to make developers kind of do your job for you, because I personally am really lazy. So a little bit of background information about myself. I'm an application security consultant, so I test people's apps. Sometimes they're before production, sometimes after, sometimes IoT devices. Pretty much anything anybody will pay me to test. And I work with a lot of DevOps shops in that kind of work. I also was a developer for 8 years prior to this. I did security engineering work, incident response, and I was also in the infantry in the Army for 4 years. So I kind of get around. But yeah, so when I'm working with software developers and APPSEC teams, I'm generally coming along like at the 11th hour, just like kicking developers right in the knee with a bunch of findings and some like app that's already in production. Then everybody hates me and there's like big fights on the phone. And so the APPSEC team started asking me, they're like, hey, how can we find these vulnerabilities earlier? You know, we're doing dynamic analysis, we're doing static analysis, and still we get just kneecapped by penetration testing on the apps way after, and the developers don't even remember the code anymore. It takes forever to fix things. So I asked them, well, have you guys ever thought about using like abuse cases as security unit tests? And everybody looks at me like I'm insane because developers are trained completely differently from security professionals. And so being able to like bridge that gap, I think is a pretty powerful thing. And when you look at the SANS like APPSEC surveys, and they're like, hey, what are some things that you should be doing? They always list abuse cases and security unit tests on there, but they don't actually tell you how to do that. And I couldn't find any good resources on how to do that. So I wrote a paper at some of the SANS reading room, and I made this presentation because when I'm doing an app test, and I do a lot of white box testing, and somebody sends me their code, and you start looking through their security unit tests, and you're like, oh man, this is going to be a terrible day for me, because when you look through their unit tests, they've already tested about 90% of what I'm about to look for. So that way, I never come along and find something at the 11th hour in those projects. So I think it's a good way to move as an industry. I'm going to give a little bit of background about DevOps today so that everybody at least kind of understands, can kind of grasp some of the problems. Talk a little bit about the security controls that I see APPSEC teams using now and how well those work. And then go through the process of taking the developers' use cases, using threat modeling to turn those into abuse cases, and then finally writing security unit tests. So that way you can automatically test for these, do regression testing. I'll talk a little bit about how I use this in consulting. Before you do anything with abuse cases, you should probably at least do these 4 things or you're going to have a bad time. So security champions are really important. If you don't have security champions, they're kind of they're your eyes and ears on those developer teams. So these are software developers that have gotten a little bit of specific training on security, and they can kind of help out everybody else and at least identify problems and find things that need to be raised up. Developer training, if you haven't trained your developers to code securely, assume they have no idea how to do anything security related. So that should be your first stop. And then use cases. This is pretty common. I don't think I've ever seen a DevOps shop that doesn't use use cases. And then unit tests, that's most everybody. I think if you're doing DevOps and you don't have some unit tests, you should probably question the way you're developing software. So DevOps. DevOps is a software development methodology. Some previous development methodologies were like waterfall, and waterfall was characterized by like really long deployment cycles. So it might be like a year from the time that you conceive of a project to the time you actually have something to deliver, which was not so bad when you have to stick security gates into that process. but the speed to market is just terrible, right? So if you finish your requirements gathering phase at a month in, it could conceivably be 23 months before a new idea actually hits a production system. Also, with waterfall, a lot of projects just were abject failures because you spend years and years developing this, and if you don't have a perfect plan and then do not deviate from it, then things are going to go awry really quickly with waterfall. So trying to get our speed to market up, we moved over to Agile. So Agile, you move from like year-long to like 2 to 6 week sprints, depending on the company. And Agile was good for speed to market, but I feel like people kind of stripped it down to bare bones. I know I used to work on a software project that was Agile, and they got rid of all the Scrum meetings because they thought they were a waste of time, and they told us we couldn't talk to the customers because that was not the way we wanted to do business. And so it just devolved into like 5 of us just throwing code on a server as fast as we could. So it got pretty bad. And I'm a little more hopeful on DevOps. I haven't seen that happen quite as often, mainly because of the focus on automation with it. So I'm optimistic about DevOps. I think it can do a lot both for the business and for security. So you kind of have to approach it from that way. And so DevOps, instead of being like that 2 to 6 week deployment cycle, you're looking at like trying to do 10 deployments in a day, which is kind of unreal. So a lot of processes don't scale very well when you try to do that. So how do you get from like these really long deployments down to super small deployments? You kind of have to get on board with the 3 ways. So you have to understand and optimize the flow of work. So you have to understand how all your requirements come in, everything that happens along the way till software is delivered to the customer. And then along that path, you're going to have bottlenecks. And work, you'll see, building up at the bottlenecks. So that's where you apply your optimization, is at those bottlenecks to open it up and let the work flow freely. So optimization is often going to be automation in DevOps. And that's one of the coolest things, because people are terrible at doing the same thing over and over again. And I myself, if I have to do something more than like once, I'm probably going to try to write a script just for my own sanity. So once you've done that, the next thing is feedback. So the second way is when one team learns something, the whole organization should learn that. So whether it worked well or didn't work, you need to make sure that it's fed back into all the teams so that they can all benefit from that knowledge. You don't have these like little tribal silos off somewhere. And then the final one is continuous improvement through experiments. For this, you're encouraged to take risks in DevOps. And you have such small deployment cycles, it's easy to figure out what's going to work and what's not, right? If you do 10 deployments a day and you try something out for 5 days, you have 50 deployments worth of experience on that to see if it helped, as opposed to waterfall, which would take you 50 years to accomplish the same thing. So with continuous improvement, one of the things I liked was Netflix with Chaos Monkey. So they wanted to improve system availability by turning off systems and by killing processes, which I think is awesome because it actually worked. So that was a really cool idea that's thinking outside the box. So that's kind of where you need to have your mindset is, I'm going to try something new. We're going to see if we can use this to help out on our projects. But DevOps is going to be characterized by these like really small deployments, a lot of automation, blameless culture. So when you're doing your feedback, you're trying to get the root cause. You're not trying to just crucify somebody for messing something up. And that's really important. And trying to empower developers to do their work without you. Right? You want the developers to be able to control that flow of work. Because if you're that bottleneck, someone's going to optimize you right out of the business. So don't be the bottleneck. So what do we do in APPSEC? Right? What are our tools? First, I want to cover in-band versus out-of-band testing. So when you hit deploy as a developer and you're pushing your code to production, it goes through a series of steps, generally to make sure that code doesn't destroy the entire world. So an in-band test is something that can run, provide feedback, and then you can either pass or fail the build based on the results of those tests. And out of band would be something that doesn't work that way. So maybe it takes too long. Maybe it takes a day or a week to run, and you're trying to deploy 10 times a day, so you can't really do that in band. Or maybe you're getting like a PDF report, and you can't automatically process that back into your system to see if that works or not, regardless of how fast it goes. So our three tools that I see most of the time are static analysis, dynamic analysis, and application penetration testing. Static analysis looks at compiled apps or source code to try to identify vulnerabilities. And this is actually not too bad for DevOps. It's also not that great at finding vulnerabilities. It has a lot of false positives, and there's some things that it just doesn't find very well, like broken access control type findings. But it runs pretty quickly. A lot of times I see developers using it in their development environment. So right as they're typing their code, they can find out, hey, am I writing a SQL injection here? And it'll beat them over the head, and they can fix it right then while it's fresh in their mind. But SaaS tools are normally going to take like minutes to hours most of the time, so they're pretty fast, and I often see this as an in-band test. Dynamic analysis, on the other hand, I usually see it take hours to days. So this is sending requests to a running system and then looking at the responses to try to identify vulnerabilities. A lot of times you can pare that down a little bit. So instead of hours to days, you can get the time reduced by using something to seed it. So you'll use like Selenium, or you can use the unit tests or integration tests that the developers have written and route those through your proxy tool like Z-Attack Proxy or Burp, and then automatically kick off a scan just on the parts of code that have changed. So I've seen people manage to get it in band doing that, but it does take a little bit of extra work. And finally, application penetration testing. That's what I do. It's very manual work. So it's a human being testing the software. And it takes a long time, usually days to weeks. Even like a microservice that has like 15 API endpoints is probably going to take me like a day to get through. And then I got to go write a report and give it to the client. So it's not typically that fast, but it does find logic vulnerabilities. So both DAST and SAST have problems saying, should user A be able to access user B's record, and being able to figure that kind of thing out? But that's what application penetration testers are very good at. Like, to me, I can look and see, hey, I'm getting somebody else's social security number here, or I'm seeing something I shouldn't be seeing. So that's kind of the advantage. So how well is that working? Not very well. I feel like it's pretty sad. We're not getting on board with DevOps. If you've read anything like the Phoenix Project or something, you need to get on board, or people are just going to push you off to the side, and then you're not doing anybody any good. So we have these old busted tools that we made for waterfall when we had these long deployment cycles, and you could tell somebody, hey, this is going to take me 2 weeks to test this thing. And they were like, that's okay. I can deal with that. But we're saying, hey, we're security. If you want to be secure, you better let us do these things and let us inject this into your cycle. So we're really slow. Most of our stuff runs on compiled apps. And it's all about the security team. And this is really not keeping in the DevOps spirit. We're saying, hey, the security team, we have these specialized tools. Come on out, and we're going to run these tools. We own this process. And that's how you become the bottleneck, because you can't possibly hire enough AppSec people to do that. IBM has a report that says there's like 100 developers per application security consultant or application security engineer. And I've seen it in practice be like 1,000 developers to a single AppSec person. So if you're out there saying, hey, look, just let me configure this DAS scanner on your app, it's not going to happen. You can't do it for 1,000 developers per AppSec person. And in the 90s, I was a QA engineer, and there's a lot of parallels between 1990s QA engineering and present day application security, right? I would come in, I would get my build, and while I was installing the software, I'd maybe write up some unit tests and use cases, and then I would just sit there and tap, tap, tap on all the keyboards. And we were just coming out with the idea of automation for that, where I could record something and then do regression testing with it. So that's kind of what we've done now with QA, is we've gotten away from that idea of somebody tapping on the keyboard, and we've gone to automation. And a lot of companies have completely just gotten rid of their QA departments because they're using these use cases and unit tests to do it instead. So a use case is going to test the software functionality. I see it in most development DevOps shops. And the developers are going to control this. So they're going to write scripts, unit and integration tests to actually go through this process in automated fashion. An example of like a use case might be, so as a user, I should be able to access my shopping cart that has these items that I want to buy. So is there something that we can use as application security people that's going to accomplish the exact same goal? And conveniently enough, there are. We have abuse cases. So it's the exact same idea, except now we're flipping it on its head. And we're testing under adverse conditions. So what happens when I send input that is generally not going to be expected? Well, one of the common arguments against this kind of thing is developers are really bad at testing their own software. I know I personally was terrible at it. But that argument didn't really hold up. That was the same thing that we said about QA. Developers can't test their own code because they only know this one path, and they're not good at deviating from it and trying different things. But we see where that kind of went for QA. They just don't exist anymore sometimes. So this is kind of what we're going to do, is help guide the developers, right? We don't expect them to be security experts, but with threat modeling, we can kind of give them hints on where to go to create these abuse cases. And then after you've created the abuse case, you just test it the same way that you were testing your use cases. So here, as an attacker, I should not be accessing somebody else's shopping cart. So this is your classic insecure direct object reference. It's my bread and butter when I'm testing apps, because most of the time people haven't checked for it because automated tools are bad at it. To try to keep this straight, I came up with a couple of phases for this process. And this is strictly for the abuse case part, so not getting into the rest of software development methodologies, because you can kind of plug this in wherever it works in your organization. So first we're going to do threat modeling, and we're going to use our threat model to generate our threats. And then we're going to create abuse cases. The developers will then write the code and the test for those, and then run those tests. And then finally, we're going to, as the APPSEC teams, we just watch what they're doing and then try to help make things better in the future. Now, threat modeling, I'm not going to go into a lot of depth because there's already a ton of material on threat modeling. Adam Shostak's book is really good, I think. But the general idea of threat modeling is you're going to create this architecture model, which is great because now, as a security team, you have an architecture model, which is better than I can say for a lot of applications that I worked on in the past, where you have no idea how it works or how things go together. And then you take that architecture model and you take a template and slap it on there, and then you get a list of threats. And then you can prioritize those threats and see how they relate to your abuse cases, or to your use cases, sorry. The Microsoft threat modeling tool is the one that I use all the time because it's the only one that supports templates right now. Mozilla CSponge and OWASP Threat Dragon are coming out, and they're supposed to be like amazing. But Threat Dragon is still like an incubator project at OWASP, so it doesn't support templates. They're on the roadmap, but they're not there yet. So you can't really use that in an enterprise just yet. And that templating process is really important because as a security team, this is your only touch point until way later on in this process. So that's why you definitely need to have those templates. And the Microsoft Threat Modeling tool is obviously heavily Microsoft-centric. Oh, it's free, by the way, so you don't have to like buy it or anything. But you will have to go in and modify their stock templates to actually get threats that are useful, or your developers will probably be like, this is stupid, and get rid of it, not use it. So the process of creating abuse cases, all you're going to do is take the existing developer use cases and then combine those with the threats that come in from your threat model. So our previous use case was, as a user, I should be able to access my shopping cart. Well, the threat would be attackers may try to directly access another user's information. So then the developer has to think, as they're writing this down, making these stories, they say, all right, how do these threats apply to my current use case? And so from this, we might come up with, as an attacker, I should not be able to access another user's card. And you can have a whole host of other threats or other abuse cases you might get from the same threat. Like, as an attacker, I should not be able to add an item to another user's cart. As an attacker, I should not be able to check out another user's cart, and so on. Another example, this is another one that I see all the time that scanners and SaaS tools are terrible at, is identifying unsecured APIs. So you have a use case here. Hey, we have to have this logging API that's available to our administrators, so it should be authenticated and like IP address limited. Well, the threat is an attacker may try to directly access that. And so your abuse case is just be, as an attacker, I should not be able to directly access this logging API. Like I was testing a thick client app one time, and I looked at it and actually had an API call called execute arbitrary SQL. And so it did exactly what you would think it did, and they obviously had like XP command shell enabled on the database server, and it ran as domain admin. So that kind of thing was a like just god-awful vulnerability that nobody was going to find, because a lot of the tools are just going to be like, oh, yep, this is fine, just continue on. Or they never found it because it was never actually called in the thick client app. So this is a good place to look with those. So for the rest of this, I'm going to use MOCHA. MOCHA just as a testing framework for Node, and I started using it because that was what my customers were using. They were using Node.js, and they were using MOCHA to do their unit tests, so that's kind of where I went. By no means am I saying that everybody needs to test their software with MOCHA. And fitting in with like that DevOps philosophy, what we need to be doing is not throwing extra work on our developers. We need to be living off the land, using what the developers are already using. So if they're using MOCHA, if they're using JUnit, whatever it is, that's what you're going to use. And this is important for acceptance and them not having to learn a whole other tool that you're chucking at them. And later on, when we start taking their unit tests and twisting them to become our security unit tests, you really don't want to have to make people write unit tests in a totally different language than they've already written them. So it'll save you a lot of trouble. So MOCHA, all right, so MOCHA has a couple of really cool things about it. You have this describe block. So the describe block separates a set of tests that all have something kind of in common. And it gives us access to 4 really important methods: before each, after, and after each. So what these do is they allow you to execute. So before each will execute a task one time at the beginning of the describe block. And that's really good if you have to say, create an account that you're going to use during testing. So you can automate that account creation process. When you run the describe block, it can create that account for you. So you can use it for all of those unit or integration tests. Then at the end, you have an after module that can clean that up, delete the account for you. You could have a before each function. In this case, what I'm doing in my before each is I'm posting to the user login page of the OWASP Juice Shop application. So this is authenticating my user, and then I get this authentication token, just pulled out of the JSON from the response body, and then I can set whatever I need to for my future calls. In this case, I'm setting the authorization bearer header and the cookie token. And a lot of times these are things that I see testing tools kind of fall flat on. When you start trying to use these weird headers and you have all this JavaScript like building things behind the scenes, this way you can automate that task and your tool won't fail you because you have complete control over what's happening. Another thing I wanted to point out was timeout. So as a consultant, I use these tests to give to customers. And timeout is really important when you do that because at my house I run over Google Fiber, so I have gigabit Ethernet going to their testing sites. And the customers don't always have that fast of a connection. So I had a couple of instances where I would give somebody some tests, they would run them, and they're like, hey, we're failing all these tests, even though we think we fixed these. And you go and look, and it's all because they're timing out. So being able to set that timeout, like in this case, it's 10 seconds. And it may not be an issue if you're doing this like internally, but for me with customers it is. Then you have your individual tests. So you designate those with IT and give the test a name. So in this case, administrators should be able to view the email addresses for all the users. So in this case, what I'm going to do is create an account and then go check to see, does that account exist? So it'll actually, yeah, this is the creation, and then this is me checking to see, is that account there? Or can I get the accounts? And then is the account there? So this is the expect module. So expect is a function of like a library called chai that goes along well with MOCHA. And so expect says, it allows you to use like plain English to say this is going to be why the conditions that pass this test. So in this case, I'm expecting the status code to be 200, which is okay. And I'm expecting that the JSON is going to have somewhere in the body the text email and the test email that I just submitted for the account. So that's generally how MOCHA is going to work. And again, don't rely solely on MOCHA. Use whatever developers want to use. Let's see. And then the last thing I want to show you about MOCHA was the output. So MOCHA, when you run it, it goes through and runs all these tests. As you can see here, it gives you like timing information. So this is saying that this test took a really long time, right? 92 milliseconds, which is really not that bad when you compare it to like dynamic application security testing, where you're going to spend 2 days sending data to the server. You can get this one specific test done in a couple of milliseconds. So here, like I ran 9 tests and they completed in 2 seconds. And if you're doing, these are all integration tests that run against the live system, and the unit tests are even faster, right? So you can execute thousands and thousands of unit tests in a couple of seconds. So those are really good ways to test your software. And that's why developers started using them to do their testing. As you can see here with our abuse case tests, these are the failures. So everything in red, it says is not good. Everything with the green check is good. And then these are the describe block headers that I used. So it kind of breaks them down for you. It gives you a summary of how many tests passed and failed and how long it took to run. And then for every failing test, it gives you really nice error messages, such as this, that are really easy to read. So this one, it puts the entire JSON response from the server in there, because that's what my test was for. And it says, I expected this massive string to not include this specific email address. So in this case, my abuse case test was, are they properly encoding the output coming from this JSON response? So I would want that to be like HTML encoded or something. And in this case, it was not. So I didn't want it to have derpy McFuggles with script alert 1 stuck in there, and it actually did have it. And then it tells you specifically where that test was. Some other confusing error messages, not quite so verbose. Expected 201 to equal 400. Right, that makes perfect sense to everybody. But what it's actually saying is I expected this green value of 400. The actual value that I observed was 201. So I expected it to fail, because this is an abuse case test, security unit test, not a actual use case test. All right, so that's MOCHA. So now the developers finally get around to actually writing the application. They might write the test before the code, so that would be like test-driven development. Test-driven development, you'll write all the tests for your application, run them, they all fail because you never wrote the code, write the code, and then run them again, and then it should pass every single test that you've written. And the developers should have some unit and integration tests for you. I still delineate between unit and integration tests. I've noticed some people do not, but I feel like it's kind of an important designation sometimes, but it does get a little wordy. So a unit test doesn't check a functional requirement, and an integration test does, which is kind of an awkward way of saying you won't see the interactions between two systems with unit tests, whereas you would with an integration test. And so this is one example of, yes, this hand dryer works just fine. You stick your hand under it, and the air blows out, and it works great. And then you have a separate unit test of, yes, I can throw my paper towel into the trash can, but as soon as you stick the two together, it's not going to work out so well. And you might have the same problem with, so a lot of times in unit tests, they'll like stub out databases. Well, it's really hard to find SQL injection vulnerabilities when you've stubbed out the database, right? It's just not gonna be there. So you have to recognize the limitations of the two. So the security unit integration tests, you're going to take those and the same idea that you had with the use cases going to abuse cases, you're doing the same thing to their existing unit integration tests. So you base these on an abuse case, and you're going to use their test that they already wrote as kind of a template for it. And this is why it's good for DevOps. It's not a ton of extra work for that developer. They've already done this as part of their job, and now they just have to tweak it a little bit a few times, and they're good. You only need to change 2 parts in most of the unit integration tests, and that's the request that you're submitting and the expectation of what you're going to get back from the server. So a few examples of that. Here we have this unit test. So this one is for redirection. In the OWASP Juice Shop application, they have this whitelisting function that's written in Node. And this whitelisting function says, if you give me a URL, I will tell you if you're allowed to redirect to that site or not. So here what we're saying is we expect this is redirect allowed module. If I give it this whitelisted address, that should give me true, right? So the function, we're not calling the web server. That's why this is just a unit test. We're just directly calling that JavaScript. Well, we can twist that into a security unit test. So if you had a threat that said somebody might include a whitelisted URL as a parameter to their bad URL. So here we have evilsite.local, and at the end we have this link to the legitimate site. And here we would expect, is redirect allowed? Now it's going to be false, right? Because now we're trying to direct outside of our whitelist. And so that's what makes this the security unit test. We just changed this function call parameter, and then we changed the expectation. Another example, I've never actually seen somebody do a unit test for their JWTs, so it's a JSON web token. And JWTs are commonly passed back and forth in authentication mechanisms now and chucked into like bearer headers and cookies. And a JWT is nothing more than a base 64 encoded and signed bit of JSON. So you can take that as an attacker and run an offline brute force against it. And if you can recover this secret they used to sign it, then you can modify that JWT and resubmit it to the server with varying effects depending on how much the application trusts the content of that JWT. So you want it to be really strong. So this is when I'm doing a manual test, one of the first things I do is I see a JWT, I pull it out and start running Hashcat or John the Ripper or something on it at the very beginning of an assessment. And then I see if I can recover that secret by the end of the test. If that's 1 day or 5 days, that's how much time I have to work on it. And that's not really a great solution, right? Because I'm trying to brute force something. And that's not a really good way to test to see if that's a good secret or not. But what you can do is include other node libraries like this PWSTR. So that checks password strength. And it kind of comes up with an entropy value for that JWT. So here we want to see, is the entropy of this default secret at least 100. And that's just an arbitrary value. You pick whatever you want. I'm not saying that that's like the perfect one or something. I just made it up. But this would take me days to reliably test. And the only other way that I've seen people test this is with like blacklisting of saying, hey, you can't use these weak secrets in your app. And then developers just like add something onto it and voila, it's like a perfect secret now. But this would still catch that. So if somebody has a bad secret, you will find it with this kind of test. Moving on to integration tests. So in this one, we're checking to see, can users check the contents of their own shopping cart? So this would be a common integration test here. We're actually going to send a request, use this agent or super agent node module to request the user's shopping cart. And then we expect to get a 200 when we do that. I'm going to switch back out of this and go look at it in here instead. So here's an example of this. After I did the slides, they released a new version of the OWASP Juice Shop application, so I had to make a few changes from the original slide. So what we have here is I'm sending this product ID, adding it to basket number 1 with a quantity of 2. So this is something that should work. And then I check, can I actually check out for that item? And that's kind of to satisfy OWASP Juice Shop for my security test. Well, all I've really changed when you come over here is the product ID and the quantity. I changed the product ID because Juice Shop won't let you add the same product twice anymore, and I didn't put in an after function or anything to clean it up. But now I'm going to add a quantity of negative 99,999. And so in Juice Shop, this allows you to make a purchase that gives you money. And this might be caught by a threat in your threat model, like users may submit out-of-bounds values to API calls. And so that's exactly what this is, out-of-bounds value being passed in. You should never have a negative number. And then here, we expect that response should be a 400 as opposed to 200. So 400 bad client request, and here 200 is what we would expect from the unit test. Then we also have some other ones, like you can test authentication for that. Let's see. So here you can test, can I do this to somebody else's shopping cart, right? And in this case, I still had negative 9,999 here with a different product ID and a different basket. So, can I add something to somebody else's shopping cart? I don't know. Let's try it out. So these are the kind of things. It's the same exact set of requests, just with slight modifications to it. And so that's kind of how you can sell this to development teams. This is something that's almost impossible for a DAS tool to find, but I can find this as a tester. And this way, your software developers can find it. And finally, we have KeyPass. So KeyPass, in Juice Shop, they have this KDBX file that's sitting out there, and you can go download it. And here what we're saying is, I should have to be an administrator to access this KDBX file. So here I'm just in the describe block that already does my administrative authentication, and I should get a 200. So when we flip that around, status not equal to 200, right? And as a consultant, I use this one, the not equal, a lot. I don't see, as internal development teams don't typically use it because they know what response they're going to give. If it's a 401 or a 403, the developers kind of have an idea. But I, as an outside tester, have no idea what they're going to do. So sometimes I'll just say, it's not going to be 200, whatever it is. I don't know. You're going to come up with something. But yeah, so it's pretty simple. And this is how you find this broken access control vulnerability there. And then the last thing I wanted to do was, just because I think it's kind of funny. So here's the OWASP Juice Shop application. And the OWASP Juice Shop application is an intentionally vulnerable web app. And as you find vulnerabilities in the OWASP Juice Shop application, it pops up these boxes to let you know, hey, you found a problem with the application. Congratulations, you solved the challenge. So I can run MOCHA against it. And these are use cases that I ran. And there were a couple of things that it tripped for, like logging in using the admin credentials. So that's nothing too serious. But you can also do MOCHA abuse case test. You can run your abuse case tests, and it just finds a ton of findings. So you can conceivably use this to automate finding all the vulnerabilities. So this is kind of the way that I use it as a consultant. Is when I find issues in an application, I might write out some of these unit and integration tests, so that way developers can do their regression testing. I was talking to one customer, and he told me it seemed a little high, but he said they spend like 8 hours trying to validate each finding from a pen test report on their applications, which is a massive drain on developers. Like that one in particular had 30 cross-site scripting vulnerabilities in that app. So if you go ahead and do the math, it's going to be like 240 hours that they're going to spend just validating my cross-site scripting findings. This works out pretty well because the developers can just see exactly what all the requests are, what all the responses are. And yeah, sometimes developers will try to do something chintzy like blacklist the word script or something to escape my tests, but really they're only hurting themselves at that point. So, but it's still useful, and then the client doesn't have to come back to me to test things. They don't come back unless everything in the script is already fixed, and then I can try to bypass functions. Because that's something that humans are good at and machines aren't necessarily perfect at right now, right? Trying to find ways to bypass these protections that developers put in. So that's a much better way for me as a consultant to spend my time rather than finding junk findings like user A accesses user B's record. So finally, now we've written and run all of our tests. And this is the first time the security team actually does work. And that's kind of what I like about it because I'm lazy. Everything else is done by the project team. And that works well for DevOps because now the developers are controlling that flow of work. So as long as you have good security champions, you've done a decent job training your developers, it's going to work out okay for you. Now, as an APPSEC team, all you're doing is checking the volume of tests that they've created and the types of tests they've made. Sometimes you'll see teams come back in and like all they've done are broken access control findings, and you're like, hey, maybe we should do some input sanitization stuff here too, guys. But that's not too terrible. You can have them put like metadata into their unit tests so you can check and easily script like, hey, what type of control are we checking here with this? In the past, I've gotten questions about code coverage. So you can use code coverage tools. They instrument the application and then determine how much of the application actually gets called in your testing. So you can use this as an application security tester to say, hey, I tested 80% of your application. And you can also use it to say your unit and integration tests test 80% of your application before it's even sent anywhere. And you just use whichever one that your developers are already using. So it's nothing new that you're adding on to them. And then you just have to come up with some kind of threshold. Unfortunately, when I tried to find an acceptable threshold, there is not an acceptable threshold for how many unit and integration tests are enough. And there's a couple reasons for that. Different software is going to need different amounts of coverage. And it's also possible to achieve 100% code coverage without actually testing all the vulnerabilities. So if you're doing an input sanitization check and you write an input sanitization routine that does nothing but say, if you have like single quote, then return fail. And if you don't have single quote, return pass. And so if I submit something that's not SQL injection, maybe I'm submitting like cross-site scripting, and you're missing characters from your blacklist, you could have already tested both code paths there, gotten 100% code coverage, and still not tested for cross-site scripting. So that's why you should never get all wrapped around the axle about how much code coverage you've actually managed to get. And then continuous improvement is our other job. We should be running the training for the developers, and you look and see what's happening. One of the ideas that I like is having mortality and morbidity conferences. So in medicine, when somebody dies and you want to figure out what went wrong, so from as soon as this person came in, what their symptoms were until the time that they died, everything that happened. And again, you're not trying to blame anybody here. That's never the goal. You're just trying to figure out what steps happened and how can we improve on this. So you can use that with people's code. You say, here's an anonymized vulnerability that we had in one of our apps. Because then it's more important to developers when it's somebody they know, even if they don't know who that person is, just the fact that it was their organization instead of, you pulling something off the news or some like open source project that they don't care about. This kind of brings it home to them. And then you can try to work to improve the code coverage. 20% probably not okay, and you want to try to get that up over time. But it allows you to show these nice trending metrics as you're improving. That way everybody can say, oh, look, we're actually like getting something out of this. And then you can try to make sure that you have that good diversity in your code coverage so that you're testing all the different types of vulnerabilities. And then super important is updating your threat model templates. So do root cause analysis. When you have a penetration test finding on your application, there's a reason that that vulnerability made it all the way to that last phase. Maybe it was already in production. So how do we stop that from happening in the future? Were we missing something in our threat model template? Is that the problem? Did something else go awry? Are dynamic tools not catching it? What happened? Why did we not find this? There's a reason, and again, not blaming anybody, but you got to find out why it happened. Using this as a consultant, these are a couple of things that I've run into. Try, whenever possible, talk to the developers about what they're going to do to fix this problem. One good example of that for me, I had a finding for they weren't enforcing their CAPTCHA on account creation. And so I wrote a test saying, hey, this test will pass when I submit this, when I submit like valid input, but an invalid CAPTCHA, and I get the server response. Well, their server response for a failed account creation was a 200 with null JSON. And so that was what I wrote my unit test for, or my integration test. I said, all right, I'm going to send this with bad CAPTCHA, and this is what I should get back. And they made it a 400 response code with error invalid CAPTCHA, which is fine. It achieved the same result, but it kind of caught me off guard because it's like, I don't know why you did something totally different than what you were doing. But it was a little bit of frustration on their side because they're like, hey, we fixed this. Why does it keep coming back? What's wrong with your test? So this was an important lesson for me. And sometimes I give these over to the security team thinking that they're going to like put them in with their regression testing, and the security teams don't want to talk to the developers about it. So they decide to like pull these off, and they'll install MOCHA on their own Linux image. And that really kind of threw me for a loop because I'm like, you guys already have these tools. Why are you starting over from ground up? But they might be doing that. And that's kind of where I also found a lot of timeout problems because they were running on some like rinky-dink VM that they stood up. So making sure that the timeouts are okay. But whenever you're doing AppSec, make sure that your security controls don't shank your business, right? If you get in the way of DevOps at an organization where it seems to be working for them, you are going to get annihilated. And that will not help anybody at your company. So don't do it. Try to come up with as many controls that are not going to put you in that bottleneck position. So that's why you try not to make your team have to go have hands-on with anything. Use developer tools whenever possible, because that will always increase your acceptance with developers. Because you're not just like foisting something on them, being like, here, just learn this new technology. When they've got stuff to do. It's hard to be a developer. You have a lot of competing priorities. But I think abuse cases and security unit tests are a great way to actually accomplish this goal. Because you can do automated testing, and it works great for regression testing. So whenever they deploy software again, if somebody goes back and modifies that piece of code, you already have the test written, and it'll pick it up right away, possibly before they even check their code in, which is glorious, so it'll never hit production. And it shifts everything onto the developer. So you're jumping on the bandwagon with this, right? You're not fighting against the rising tide of DevOps, because you will definitely lose. And then you just monitor and assist. And the last one doesn't necessarily have anything to do with unit integration tests, but I see so many AppSec teams just being mean to developers. So don't sit there and blame them. Like I had a test, and the AppSec team was furious that it took like 6 months to get this fix in on this poor overworked developer, and they were trying everything they could to get me to say that the developer had done a bad job. And I'm like, look, no, it's not the developer did a bad job. You have one developer doing this thing as like part-time duty. This is your expectation. These fixes should go in with the same priority. If you have a critical security vulnerability, it should be handled about the same as if you have a critical functionality vulnerability or critical functionality problem in your application. If your app crashes, or if your app has like this just god-awful SQL injection vulnerability in it, you should treat those things with the same level of respect. And so if that's okay for you to have a functional problem for 6 months, then that's fine, and that's how you should treat it. But that's pretty much it. Thanks everybody for coming out. I know Sunday's rough, so thanks. Anybody have any questions? Yeah. Yeah. So the paper is up on the Sands reading room. What's that? Stephen Deck, and it's. I want to say it's like abuse case testing in DevOps or something like that. But yeah, so the paper's up on there, so that way it's a little bit better explained and has some research behind it. I'm just Ranger Cha on GitHub. So, and I put all my unit and integration tests that I use in the presentation on there too. And OWASP Juice Shop is free, so you can go grab that. I'm running on Docker in Cali, so you can just throw it out there and it works just fine that way. So it's a good way to try to pitch this to people, I think. So, do you have a question? Yeah, so the question is, if you have somebody writing requirements who's not going to be a developer, and then that person doesn't include a lot of these things as requirements, right? I guess if the developers are already on board, the developers can have, so if they're allowed to write their own like use cases for it, they can potentially handle some of that. But I would definitely, I mean, when I worked on internal app teams for a long time before I went into consulting, and I would go do like lunch and learn workshops with people and just try to show them the benefits of it. And the other thing is just beating people over the head with metrics. I love metrics, and I feel like application stuff, it's really easy to get good metrics on this, right? You already are running these things through. You know how many errors that they're having come back on the application. So like if they're not doing error handling in their code and it gets to production, theoretically, there should be some error handling issues in the actual production app. And so you can say, like, keep trending lists of those and be like, hey, look, this is requiring us all to do all this rework on things. And with DevOps, you're trying to do it as close to the code as possible, because you get and this isn't like a total DevOps presentation, but with DevOps, one of the big benefits is the developers find out I've made a mistake like right after they've written the code. So if you do 10 deployments a day, that developer goes to push to production, something doesn't work right, they know, and they just finished working on that. So it's not so bad. You're not coming back in 6 months later trying to do this, and the bugs cost you $1 bajillion to fix at that point, right? So it's a monetary thing, in my opinion, if you can push that left as much as possible, and then you can build like business cases. So that's why it's just important to find metrics that are going to support what you are, like your agenda, and then try to weasel those into your AppSec teams. That's what I always did, because as soon as I put like you always want all your lines to like go the same way on things, and so like we'd have these lines like that are supposed to be trending down, and as soon as my boss would go and start briefing that in front of like the CIO and everything, the CIO would be like, why in the name of God is this line going up? And you're like, well, because we're not doing this. And then you have the answer ready, and you're like, hey, look, if we can get this in here, then it's going to help us out and make that line go down. And so as long as you can deliver on that promise, it'll work out well for you. Anybody else? All right, thanks everybody for coming. I appreciate having an audience. It's good not being alone.